Anyone can tell me what is the module 4 related to the tribology syllabus? It's been displayed in the PPT also. Can you at least name the title? Hello, I need a reply. What is the title of the module 4 we are supposed to start up with?
Plain slider bearings with fixed or pivoted shoe and hydrostatic lubrication.
Yes, so this is the part what you will be dealing. So you have two bifurcations here. One is related to plain slider bearing, and other one is related to hydrostatic lubrication. So in 2015 scheme, they had only hydrostatic lubrication. Even in module 3, only half part was there. But in 2017 scheme, there is a slight modification, and hence the syllabus has also been enhanced, and hence it is taking time for us to complete, right? So here also you have two parts in module 4. So I'll start off with hydrostatic lubrication and then go for plain slider bearings. Why? Because we have completed hydrodynamic lubrication associated with bearings. So it's better to go with hydrostatic, complete, and then go for plain slider bearing. So in this aspect, before going on, I just wanted to show the module 4. It consists of two parts, right? So currently we are focusing with respect to hydrostatic bearing. In this, you have all the introduction stuffs associated with hydrostatic lubrication. Then we have to go ahead with related to what is hydrostatic step bearing, how the working principle of it is associated. Then we need to derive an equation for load carrying capacity as we had in hydrodynamic journal bearing, right? So we have to show an derivation part. Here the derivation is there. You need to show the derivation, right, by using hydrostatic step bearing. So once these derivations are done, we have the numerical problems what we need to solve. So after completion of this, then we'll go for plain slider bearing. Here also you should analyze how the pressure has been distributed like we did in hydrodynamic, right? Similarly, here also you need to calculate the load carrying capacity of it, what is the coefficient of friction, the frictional resistance associated with fixed and pivoted shoe bearing. Then also you need to identify the center of pressure. So once you are aware about all these terminologies, again we have the numericals what we need to solve. So be clear enough in understanding the concepts and the derivation, because you need to use these equations to solve the problems. So you usually get the numericals in module 4 as well as module 3, right? So be careful and read well. So with this, I just wanted to start with hydrostatic lubrication. But it is not a new word for you people. We have dealt the classification of lubrications when we studied the lubrication part in our tribology. So we have different classifications based on the thickness of the film and other factors as well. So in that, hydrostatic lubrication is one part. So we have dealt already with hydrodynamic lubrication, right? And how to solve the problems associated with hydrodynamic journal bearing. Full idealized journal bearing also we have dealt. So similarly, now we have to go on with hydrostatic lubrication. So I don't want to dig on into the classification of the lubrication again, but still for your reference, I have focused the terminology called lubrication regime. So this lubrication regime usually determines what is the thickness of the fluid film we are using. So based on the thickness of the fluid film, you can categorize that either it is an hydrostatic or hydrodynamic, whether it is coming into under the section of fluid film, or is it elasto hydrodynamic lubrication, or is it mixed lubrication, or it is boundary lubrication. So this is a huge wide area of classification. Just for your reference as a prerequisite, in that we are focusing in hydrostatic lubrication. So this hydrostatic lubrication, you should be very clear, we are focusing under the section of fluid film lubricant, right? So here it mainly depends upon what is the thickness of the fluid film we are using. So in this type of lubrication regime, we usually use hydrostatic lubrication or hydrodynamic lubrication when you need to support an heavily loaded bearing. Okay, so here you see that the load is which has been substantiated on the bearing is supported by the fluid or the film of the lubricant what we are using. So why do we use this? To avoid solid solid contact. So if solid solid contact, in the sense if the journal and the bearing contact has come into picture, so while revolving or sliding, it results in wear and friction, and hence we need a media to separate solid solid contact, and hence we'll be using a lubricant of a specified thickness of the fluid film. So based on that, we have two sections. One is hydrostatic lubrication, another one is the hydrodynamic. You know what you mean by hydrodynamic lubrication already, even about hydrostatic. But still, I just want to put forward one statement before we start. So here in hydrostatic, the name itself suggests it is static. Like the fluid film, what you have is an static one. You need some external pressure so that the fluid will be in movement. So here, the same reason it is mentioned as hydrostatic, wherein you need an external pressure has to be applied to the lubricant across the contact area so that you can maintain the fluid film as per the requirement without squeezing out, or else the fluid film in between the contacts across the bearing will be squeezed out. So in order to overcome that, we need an external pressure to make the lubricant in proper position as per the requirement. And since the fluid here is stationary, and hence we call that as an hydrostatic lubrication. So with this, we just wanted to move further. So now a question might come into your mind, like we have studied already hydrodynamic lubrication, it is working well. We have studied like fully loaded uh, this one hydrodynamic journal bearing, right, which is also heavily loaded one for hydrodynamic journal bearing. So what is the need for going hydrostatic? So you should be knowing the difference when to use hydrodynamic lubrication and when to use hydrostatic lubrication. So you know what are the drawbacks and the key important parameters in case of an hydrodynamic lubrication. So what are the specific amenities of an hydrodynamic lubrication is, you can see that here the surface remains separated by a fluid film, but you don't need an external pressure in order to get the required relative moment. So that is one thing. And also the required pressure could be built by physical wedge pressure. So we have studied various mechanisms related to hydrodynamic lubrication. So these mechanisms will help you to develop the required pressure distribution. So it could be achieved in two media in case of hydrodynamic lubrication. And also one more plus point is it is always associated with low power loss. There is no much loss in case of hydrodynamic lubrication type of bearings. And one more important feature, it is very economical. Why? It is cheap and reliable. You can rely on this type of journal bearing for a longer extent. Even though it has so much of plus point, we are in need of hydrostatic lubrication. Why? Because it has some drawbacks which are associated. Always hydrodynamic lubrication operates under high speed, so it cannot operate at lower speed. So this is one of the drawback. And second thing is the fluid film which is associated across the inlet of the oil let. What happens is it will break down during the starting and stopping of a machine. When the machine starts on and off, at the time the fluid film gets break down. So this is one more drawback. And lastly, the third one is in case of this type of bearings, the hydrodynamic journal bearings, or I mean to say, so the shaft always runs eccentrically, and hence what happens that it has a low position accuracy. So due to this, we need something better in order to overcome this drawbacks. So to overcome this drawbacks, so other class of classification came into picture, which is nothing but our hydrostatic lubrication. So what are the important features associated with hydrostatic lubrication? So it can meet the drawbacks which was associated with hydrodynamic lubrication. So that is the main important features of it. The very first thing is it has very low friction. Okay, so compared to that of hydrodynamic journal bearing, here if you use hydrostatic lubrication, the amount of friction which comes into picture is comparatively very low. And second is, it has a high load bearing capacity even across the low speed. This was a major drawback in case of hydrodynamic lubrication, right? So this was overcome by hydrostatic type of lubrication, where you can run the journal bearing at even low speed and have high load carrying capacity. So this is a very good plus point of hydrostatic lubrication. And lastly, here the low position accuracy was associated because the shaft runs with respect to eccentrically, wherein here it had high positional accuracy. Okay, so that was the other one important plus point. So these plus points help to implement hydrostatic lubrication based journal bearings also. And hence there is a need for you people to understand about hydrostatic lubrication and the bearings associated with hydrostatic type of lubrication film. So these are the key important things what you have to understand. Apart from that, there are some characteristics what you have to know. So any doubt until here? Is it clear enough? Are you people there? Hello.
Yes, ma'am.
Yeah, so be attentive. I need the presence of all students here. So finally, now you know what is the difference between hydrostatic lubrication and hydrodynamic lubrication. So our duty is now to go ahead with hydrostatic lubrication. So when I tell hydrostatic lubrication, there will be some key parameters of the lubrication what we are using here. So what you have to understand here is basically you know what you mean by an lubrication, what are the functions of it. So I don't want to run again. So it mainly reduces the friction and wear. It helps to keep the contact area surfaces cool enough with removing the amount of heat which has been released due to the relative motion, and also it minimizes the oxidation of the metals across the contact surface. So due to these reasons we use the lubricants, right? So this is one of the thing. The same thing has been mentioned over here. So why we use hydrostatic lubrication, you know exactly. I have told you the difference between the hydrostatic and hydrodynamic. So in case of hydrostatic, an external pressure is needed to get the required position of the oil film. So this type of lubricant in which it is associated with the bearing, it is usually called as hydrostatic bearings. If the bearings are using hydrostatic lubrication, so then what name we term is nothing but hydrostatic bearings, and it could be also called as hydrostatic step bearing. Okay, so these are the two names what you have to keep in mind. Whether in the examination if they ask you hydrostatic bearings or hydrostatic step bearings, one and the same. So if they ask you the schematic arrangement of an hydrostatic step bearing, you need to draw the diagram and explain it properly. And later you have a derivation for load bearing capacity. So for that again you have to write the diagram of the cross section and explain. If they ask you to write a brief note on hydrostatic lubrication and hydrostatic bearing, you should then start telling about the lubrication regime and speak about what is hydrostatic lubrication exactly, how it overcomes the drawbacks of hydrodynamic lubrication. So all these things what I explained you currently, you need to write in your own words in a proper way. If even though you know the concept, you have to present properly. So then only the evaluator will come to know whether you know exactly or not. So this is the thing what you have to keep in mind. So due to this plus points of hydrostatic lubrication, you can see that these type of hydrostatic bearings are used in vertical turbo generators. It is used in ball mills. It is used in various precision measuring instruments. So turbo generators are mainly used in generation of electrical powers with the help of using water as a source, and hence the name turbo generator. So it is mainly used in vertical turbo generator. And this hydrostatic lubrication, it is also used in ball mills. Ball mills are the equipment which are used to synthesize the nanomaterials. Okay, irrespective of any size you put into the vial of the ball mill, it helps to blend and get a homogeneous powder of required particle size at nano level. So even there, due to continuous rotation of clockwise and anti-clockwise, the friction can come into picture. So there you cannot use hydrodynamic lubrication because ball mills are operated at very minimum speed, like it is like around 300 to 350 rpm. Okay, so since it runs at a very low speed, you cannot go with hydrodynamic, you have to go with hydrostatic, but still it should be having maximum load bearing capacity. So with respect to the requirement, you have to select whether you go with hydrostatic or hydrodynamic lubrication. And also in precision measuring instruments, these are also very complicated and expensive equipments which are being operated to determine some functional properties of smart materials as well, right? So here also you need the results should be very accurate, right? So for that you cannot go with hydrodynamic because there it moves eccentrically and hence the accuracy with respect to position is not so good, wherein you need a measuring instrument with proper accuracy, it is always better to go with hydrostatic lubrication. So these are the examples in which the hydrostatic bearings are mainly used. So after that, you should know that I told that in case of hydrostatic lubrication, you need an external pump, so which helps in sending the required pressure for the fluid film. So we need an external media. So how you develop the required pressure? You have to use an external pump so that you will apply pressure for the inlet of the oil, and hence the pressure of the oil across the inlet will be higher. So if this is the inlet, P suffix naught will be the pressure of the oil within the inlet. So you'll be having a pump which will supply the oil with particular pressure so that the required pressure of the film will be associated with. So this is just to make you realize the use of a pump to develop an external pressure for the oil supply across the inlet oil to get the required thickness of the film and to see that the movement of the bearing is going on properly, smoothly with reduced amount of wear and friction. So I just wanted to show you the diagram mainly, and hence I have focused on this image. So now almost the concepts of hydrostatic lubrication is clear enough. So now we should associate this concept of hydrostatic lubrication to our bearing system. And hence it is nothing but hydrostatic bearing system. I told that it has two names, hydrostatic bearing as well as hydrostatic step bearing. You'll come to know why the name step bearing has been given little bit later. So before going to hydrostatic bearing system, your hydrostatic step bearing system, you should understand how the formation of the fluid film come across in an hydrostatic bearing system. And hence I've just taken a copyright information from Mr. Ripple, who has evaluated this concept in very long ago, before around 1963. Right, so he has explained all the four stages, exactly what happens. So basically they have just shown you the sectional view related to our fluid formation, not the entire figure out. So here you can see this is the initial position where the pump is off. Pump is off in the sense the required pressure is not being supplied, right? So the initial stage. So you will be having a bearing runner here. So next to bearing runner, you'll be having a bearing pad, right? So in between this bearing runner and bearing pad, you'll be having a bearing recess. So here you'll be having an surface which supports the bearing pad. So this will, you will be having an like pressure indicator connected here, which shows what is the pressure across the recess. And similarly, here you will be having an supply pressure. The supply pressure will be measured here by one more indicator. Usually the supply pressure is represented by P suffix S, and the recess pressure is mentioned by P suffix R. Okay, I'll tell you in depth how the process takes place. Now I'm just showing you the fluid film formation. So initially when the pump is off, PS will be equal to 0 and PR also will be equal to 0 because there is no required pressure developed. But still you have the load which has been subjected here in the direction as shown in the diagram. So next, this is the second figure. So where the pressure is built up already. So why the pressure is built up? You have supplied the oil with respect to the power pump, to the pump with respect to some pressure. And hence, now the indicator here is showing some value. So this is a supply pressure value which is greater than 0. It is not equal to 0. In the first position, it was equal to 0. Now it is greater than 0, right? So you'll be having a restrictor here. So it will be usually used as a compensator. So if any eye pressure has been supplied, so it will filter or it will reduce, which is the unwanted part. Okay. So you'll be having a restrictor here. So if everything is normal, so then this supplied pressure with respect to the oil flow will be made to pass through here. And even due to this pressure, so what happens even across the recess, so this is the bearing recess, the white one, even across the bearing recess the pressure will go high, it will be greater than 0, right? And this pressure which is developed here should be equal to that of the load distribution which is coming from the top end. So both should nullify, then only it will be in equilibrium condition, then then it will not cause in around wear or friction. If both are not matching, so if it is not in equilibrium condition, then it results in all like friction, the vibration, the noise, and finally scrap of the surface across the contact area when the wear increases. So you should see that the required pressure is distributed across the oil film. If that is not being done, then it results in friction and wear. So this is how the pressure distribution happens in case of hydrostatic bearing system. So this is the second stage. And next comes the third stage. So what is the third stage basically here? The pressure time recess area equals the normal applied load. So this is just shown here. Like the pressure distribution and the load in the downward direction. The equilibrium part, what I told here, is been represented in the third condition. Means this one shows that the pressure which has been developed and it is distributed equally across the bearing recess should be equal to the load which is acting in the normal direction. So both will be going in opposite direction, but the magnitude remains the same and it gets nullified, and you can claim that it is an equilibrium condition. So once this is achieved, then the operating of the bearing comes into picture. Initially in the first stage, what happens? The pressure will be 0 across the recess and across the supply. So when the supply is on, the pressure is built, the value of both will be greater than 0, right? So here, when in the equilibrium condition, the direction of the pressure developed will be in the opposite direction. So that you have to show through the indicator. And finally, in the last stage, the bearing is in operating condition, right? So due to the movement, the minimum film thickness of the oil will be generated across the contact area between the journal and the bearing. And this will be the load. So the profile of the pressure distribution will be shown as shown in the diagram over here. So this is how basically the distribution of the pressure happens and the formation of the fluid film and how the pressure is built in. So all these processes happens in case of an hydrostatic bearing system. So hope this concept is clear. Any doubts associated with this? Is it clear enough?
No, but
Yes, ma'am.
Okay. So once the concept of formation of fluid film is known, and also be attentive and keep the terminologies in your mind, because while solving the problem, there will be condition like PR is equal to 0, PS is equal to 0, sometimes PS is equal to PR. So you should be knowing what are these. So if you listen now, at that time you won't face the problem. So once the formation of fluid film is understood, you should be knowing some general characteristics of an hydrostatic bearings. So what are the basic characteristics of an hydrostatic bearings? So here you have to see that the hydrostatic films which are being developed will be of a thickness up to 100 microns. So this is the upper limit wherein you can use a hydrostatic film of this amount of thickness. Remember, it won't be in mm, it is in microns, 100 microns only. Okay, so this is one thing you have to keep in mind. And second thing is, whenever you use hydrostatic lubrication, a large amount of frictional problems are totally eliminated, because in the beginning only I told you that hydrostatic bearings are used to overcome the drawbacks of hydrodynamic. So mainly it has very low frictional values, I told you in the beginning. Since it has very low frictional values, the frictional problems are totally eliminated in case of hydrostatic lubrication. So that you have to understand. And thirdly, hydrostatic bearings usually and always possess zero static friction, and it has high loading capacity and stiffness value. So in case of hydrostatic bearings, it has a zero static friction, high load bearing capacity even at low speed, and it has a good stiffness value. This is one more characteristic. And due to highest stiffness value, what happens is the self-aligning capability is comparatively good, and it has minimum flow. The self-aligning capability and the minimum flow is obtained with the smallest film thickness. Means to say, even in hydrodynamic journal bearing, we used to have the film thickness, the minimum and the maximum film thickness we used to evaluate. And here it is claimed that this stiffness property of hydrostatic bearing and self-aligning capabilities could be achieved even in very small film thickness, because the frictional values are comparatively low. So that even with the minimum amount of film thickness, you can achieve good relative motion across the contact surfaces without any wear and friction. So this is the requirement. So we need a very smallest film thickness of an lubricant. And last one, what you have to understand is hydrodynamic bearings are always associated with externally pressurized lubricant supply. You cannot rely on an inbuilt developed pressurization media here. Since we rely on a pressurized lubricant, so we also sometimes call this bearings as hybrid bearings. Okay, so these are key characteristics of an hydrostatic bearings. So once the key characteristics of hydrostatic bearings is clear, and once the formation of fluid film in an hydrostatic bearing is clear, so now you should understand how the entire process comes into picture in an hydrostatic bearing. So I've just shown you a small sketch, a schematic one, to represent an hydrostatic bearing, okay, with a circular step pad. So it is also called as hydrostatic bearing or hydrostatic step bearing. So it has two names. Both of the thing is same, right? So here you can see the schematic picture. So what do you understand from this diagram over here? So you have a runner as explained you in the previous slide. So this is a bearing runner. The same thing has been mentioned over here. This is a bearing runner, and the bearing runner and the recess will not be in contact. Remember, it will be separated by a film thickness wherein you will apply your oil film or lubricant film, which whatever you have to pass through the inlet. So this gap is provided for that. It is a film thickness, fluid film thickness. So that is being given by the letter small h, as we used even in hydrodynamic bearing also. So next part is called as the recess. I'll let you know what you mean by recess. And this is supported by a supporting media which is called as an land. So this is a part of the sectional view of your hydrostatic bearing. So we are focusing on the external media through which the pressure is increased. So you'll be having a compensating element, so which will control and provide the required pressure. Sometimes what happens that the supply pressure is higher and the required pressure might be little lesser. So you need to compensate the variations and see that the optimized amount of pressure is being passed through the recess. And hence we have here an compensating element. So here how the pressure will be developed, you will be having a tank with the oil. So this tank will be connected to one pump, right? So you'll be having a valve over here. So the oil which is coming through the pump at some amount of pressure will be made to pass through the filter here. So if any impurities are there, it will be filtered out, and this filtered pressure developed oil will be made to pass through the compensating element. If PS and required pressure is same, so then there will be no compensation. Directly the entire amount of supply pressure will be made to pass through the resist. If the supplied pressure is comparatively higher, so then in the compensating element, only the required pressure will be transferred to the resist, and the remaining amount of the pressure on the remaining amount of the oil with the excess pressure will be made to pass through the pressure relief valve. So this pressure relief valve will relieve the pressure associated with the oil which is passing through it. So once the entire pressure of the oil has been relieved, so the valve here opens. So the normal oil or the lubricant will pass through with zero pressure or negligible one, and it comes back to the tank. It will be in the reservoir until and unless for the next use when needed it will be used. And also, suppose it happens in very rare case. So you are supplying the pressure in such a way what has been required. So the required pressure has been developed over here. So that will balance with respect to the normal load, and it will be in equilibrium condition. If still there is any ooze out of the oil film, if due to variation of the pressure, so some amount of oil will be squeezed out. So that is also termed to be as a leakage. So this leakage of oil, which comes in rare cases, will be made to pass through the return line. So you'll be having a return line to return the oil which are squeezed out due to leakage. So that oil should not be wasted anywhere, and hence you have a return line which helps in transferring the oil back to the tank. So this is how an hydrostatic bearing works. Hope this is clear. Any doubts associated with this?
No, ma'am.
Yes. So now you have to know some terminologies exactly. So now you know that a pump is used to draw the fluid from tank to the bearing through an line filter. So the lubricant which is under the pressure due to external pump, that is being termed to be as P suffix S. I have just written S here, it is P suffix S. So this will be nothing but the pressure supplied to the bearing before entering the pocket or the central recess. So this is the recess. So this is the pressure through which it is operating before it enters the recess across the center, and hence if they ask you to determine the pressure of the oil before entering the recess, you should identify that it is P suffix S and it is not P suffix R. That's why I'm stressing you. Okay, and later it passes through the compensating element. So this is like a barrier restrictor to reduce the pressure if it is high. So the pressure which is coming out through the restrictor, which is passed through the recess, will be having a lower value. Sometimes value, if PS value is given, if they ask you to determine the value of PR, and if your value of PR is higher than that of the PS what you have calculated, then you can understand that the calculation what you have made is wrong. Always remember that the pressure of the oil which is passing outside the compensating element will be always lower than that of PS. So the value of PR will be comparatively lower than that of PS. If in rare cases PS will be equal to PR, okay, but it cannot be greater than PS. That thing you have to remember. So this oil film of required pressure which is passing through the compensating element will then passes to the bearing across the narrow gap. So where is your narrow gap? So this is the narrow gap H. So here it passes through and it forms the required oil film formation as I explained you in this diagram. So it occupies the space between the runner or the slider. So whatever it is, the bearing land. So we have a bearing land here. So this is the bearing land on which you have the recess. So it occupies the space between the runner and the bearing land. You can just tell land or bearing land, both are same, but you should be knowing the terminologies exactly. And one more thing what you have to understand is the depth of recess will be larger than that of the gap. So what is recess? So you have a recess over here. So the depth of the recess as per the design criteria, it should be higher than that of the gap which has been provided. Okay, sometimes while calculation, if in rare, they ask you the depth of recess, and if the calculated value is like lesser than that of the film thickness, again it is a wrong calculation what you have done. So this is just and check out values for the verification aspects. So that will be helpful for you in solving the problem. So that you have to understand the depth of the recess is always larger than the gap of the oil film. So the compensating element, you know, it is used to vary the pressure of the lubricant which has been supplied from tank to that of the recess. So associated with it, you will be having PR and PS. But usually the difference between the PR and PS mainly depends upon the applied thrust load. So how much is the difference you're getting between PR and PS mainly depends upon the load which has been applied in the normal direction. So that also you have to keep in mind. So these are the key features what you have to understand. Suppose if they ask you to explain a hydrostatic step bearing with a schematic diagram, you should be able to tell about what you mean by hydrostatic bearing, what are its key characteristics. Then you will draw the diagram and explain its important features. I explained the working principle orally, right? So even looking in the diagram, you can explain it orally, and you can tell the terminologies, how it relates, when the pressure drops, when it is higher, which gap is higher than which one. So all those things you should tell. So, and also the difference between PR and PS mainly depends upon the applied thrust load. So all these has to be included if they ask you to explain. Any doubts associated with this?
No, ma'am.
Is it clear?
Yes, ma'am.
Okay, so this is about the hydrostatic bearing, the hydrostatic step bearing. So we were telling like to develop the pressure to reduce. How we will? We should be having some mechanism associated with the pump, right? So the pump will be connected to some valve. So that valve will help to control the pressure through which the oil is spilled out across our recess of a bearing. So you should think about which type of valve is essential to get the required pressure. So this everything you have to do trial and error and check before going into running of an hydrostatic bearing, because you'll be aware of what is the load which has been applied on your hydrostatic bearing. So based on that, what is the pressure which has to be developed, that has to be cross checked, and only that much amount of pressure has to be transferred. Even though there is a slight variation across PS and PR, it is okay. But if there is a huge difference between the supply and the required pressure, so there is a chances of more leakages. If there are more chances of leakages, it gets squeezed out and the amount of oil which is coming through the return oil will be higher. So you have to see that the mechanism what you are using across the valve is a proper one, so that you won't get any leakages, or else again it becomes a two directional flow analysis and still the derivation part will be complicated. While solving the problem, we always assume the leakages are nil, right? So to go abide to the rules, it's always better to use a proper compensating element. Even the compensating elements plays a vital role. So basically in hydrostatic bearing, we go on with three type of compensating elements. One is the capillary tube, second is the orifice valve, and third one is the constant flow valve. So what happens here basically? So either if you use capillary or orifice type of valve, so you can see that you will always have a constant supply of the pressure system. So that is the main need. If you need a constant supply of the pressure across the oil what you are passing on, it's better to go with capillary or the orifice type of valve, the first and the second. So in this case, the PS value is always kept constant, and only PR is varied depending upon the load which has been applied. It is more simpler because no need to vary here. The PS value varying isn't troublesome work, because you take the oil from the tank, it passes through the pump, you have a valve, it filters, and again if the pressure of the supply of oil film is very high, and if it has to be altered every time, then initial setting arrangement will be time consuming. So for that purpose, they will assume here PS value to be constant enough. So if you use either capillary tube, yeah, orifice valve, in both the thing, PS will be held constant. So this value will be constant. Only the oil which passes through the compensating element, here you will be having the valve. So it could be either capillary, orifice, or constant flow valve. So this type of valve mechanism will be associated in this compensating element. So this valve, what you have used, will be helpful to reduce the pressure as per the requirement. So how you reduce the pressure? You will check what is the load supplied, because the load acting in the downward direction should be equal to the pressure which is coming in the upward direction. Both should be in equilibrium. As per that, you have to check the pressure and compensate it accordingly. So this will, compensating element will fine tune the pressure as per the requirement. So that much amount of pressure will be made to pass through the resist, and you will be having the load which is coming down. So both will nullify and it will remain in equilibrium, and the required pressure is developed across the oil film, and hence the bearing moves smoothly across the low speed with static frictional condition, means to say low frictional values. So this is the way how it works in case of capillary tube and orifice valve. And lastly, we have the last category, which is the constant flow valve. So what happens in case of constant flow valve? In this, you can see the flow is generally held constant. But how? By pressure compensated. So how the pressures are compensated? Here they are going to use flow regulating valves. So in first one it is capillary tube, second is orifice. In case of constant flow valve, they'll be using a regulating valves, so which will regulate the required amount of pressure. So that is the thing which happens in case of constant flow valve. So these are the three types of compensating elements which could be used in here in this section of an hydrostatic bearing. So based on the requirement or based on the load condition, you can fine tune the type of compensating element is used, so that there is no more difficulty in getting the required PR value. So that is the main agenda. If the required pressure is not obtained, so then it might result in the leakages and squeezing out of the oil. So to overcome that, you have to use a proper compensating element, so that all the things associated with the leakages could be overcome, and even you will be having a null friction and wear, and so that you can have a high load bearing capacity when the bearing is running at a very low speed. So this completes the hydrostatic step bearing phenomena, right? So this, if they ask you, you have to explain until here. So after that, we have the load carrying capacity and rate of oil flow. So here we have a derivation, what we have to derive. So we have a simple load carrying capacity equation derivation in your syllabus for hydrostatic bearing. Also, what is the rate of oil flow? That also has to be determined. So this you will be studying. So now it is 12:45. I think in tomorrow's class we'll start up with. So I'll just explain you the sketch. So the same thing what you have studied. So that part has been cut and magnified over here, right? So this is like the shaft and where the load has been acting, and this is the pocket through which the oil supply is made to pass through. right? So you have an land here and you have a gap here in between. So that is the film thickness gap. Okay, so the amount of oil will be associated here with the required thickness, and the rate of movement with which the oil will be flowing also will be determined later by using the derivation part. So this is the thing what you have to understand. So based on the pressure development, you will show the variation of the pressure across the inlet within the pipe, because this is the oil inlet. So when the pressure is going with some pressure, so the variation of the pressure within the inlet valve here for the oil is being shown, how it has been distributed. Okay, so this you have the radius of the journal and the other parts, right? So we will be dealing related to that in the next class. We have a derivation. So this derivation, everyone kindly do attend. It is also frequently asked question. So they usually ask the derivation for load carrying capacity, including rate of flow sometimes, and separately also. It is a common thing frequently asked. If they ask you the derivation part in hydrodynamic bearing, they'll ask you the numerical in the other part of module 4. If you get the load carrying capacity derivation in the plane slider bearing, so they can ask you the problem in case of hydrostatic bearing. So you should be knowing the derivations in both the parts and also problem solving abilities, so that you can easily score marks. It is not like theoretical way where you have to write stories. It is a kind of derivations. If you are full with derivation, you will get full marks. If you solve properly, you will get full marks. So it is easy to score marks in these subjects, and there is nothing much to mug up also. So tomorrow, first hour, we'll be starting with the derivation part. I hope the concepts related to hydrostatic bearing is clear, and hydrostatic lubrication aspects also. Any doubts associated with it?
No, ma'am.
Only Varun is telling. What about the others? Are they alive? Chaitanya? Chaitanya, you're there? Hello? See, those who will be attentive and respond to the questions, only those will be given attendance from hereafter. Shiv Pavan, where were you until now?
Here only, ma'am.
Here only. Okay. So what did you understand in today's class then, Shiv Pavan?
Studying about hydrostatic lubrication of the bearing and derivation about it.
Okay, okay. Hope the things were clear enough.
Yes, ma'am.
Yes. Fine then. I'll just call on the attendance now. Abdul Khalik Pasha. Abdul Khalik Pasha. I think it's not there. Everyone can type your name and USN in the chat room as well. Akhil KV.
Yes, ma'am.
Anil Kumar.
Present, ma'am.
Okay. Ankesh Aman. Ankesh Aman is absent. I don't know, continuously is absent for 2 class. Gautam Krishna. Gautam Krishna is absent. Balaji VR.
Yes, ma'am.
Belder Mohammed.
Yes, ma'am.
Chaitanya.
Yes, ma'am.
Chetan Kumar.
Present, ma'am.
Dheeraj.
Yes, ma'am.
Ishant.
Yes, ma'am.
Harshit.
Yes, ma'am.
Himanka. Himanka. Absent. Kanishka.
Yes, ma'am.
Kanishka, be at regular for the class.
Yes, ma'am.
Alternatively, you are absent. Why? What is the reason? Still, you are not back to your home?
No, ma'am.
Why? What is the reason?
I'm at my grandparents' home. I'll be back next week.
Okay, okay. Nagamurli Krishna,
Yes, ma'am.
Kunal Raj,
Present, ma'am.
Danush is not there. Mohammad Ayan,
Present, ma'am.
Mohammad Junaid, Mohammad Junaid, Sri Prasad,
Yes, ma'am.
Niharika,
Yes, ma'am.
Nihar Venkat Sai,
Yes, ma'am.
Nikhil Lar,
Yes, ma'am.
Neerab,
Yes, ma'am.
Prajwal S. Bhatt,
Present, ma'am.
Rishabh,
Present, ma'am.
Rohan, Rohan Kaglakar, absent. Roshan Yadav, Roshan, Suman Sagar,
Present, ma'am.
Sagar Dutt Mathur, Sagar, Sagar GV, Sanjay Raghav, Sanjay Raghav is absent. Shobit, Shobit, okay. Siddharth, Siddharth B,
Present, ma'am.
Siddharth Sridhar,
Yes,
Subramanya,
ma'am.
okay. Subramanya,
Yeah.
Tirumana Sethi Rohan,
Yes, ma'am.
Sanjay Raghav, okay, he's present. Rohan is present. Ullas,
Present, ma'am.
Vidyan Prakash,
Present, ma'am.
Varun,
Yeah, ma'am.
Pavan, Pavan,
Present, ma'am. Present, ma'am.
yeah. Danush,
Ma'am, present, ma'am.
okay. Dhyanesh,
Yes, ma'am.
Gunasagar,
Present, ma'am.
Meghanatha, Meghanatha, absent. Rasik Varun, Rasik, are you there? Absent. Shiv Krishna, Shiv Krishna, Shreyas, Shreyas, Srinivasalu, Srinivasalu, absent. Yogananda,
Present, ma'am.
Kiranar, Kiranar, Ranveer Singh Chauhan, mic is not working. Are you there? You please call me later, Ranveer Singh. A huge lot of attendance loss for you. Only you have attended 8 classes on 30. It will be very difficult at the end. Gautam Sai,
Present, ma'am.
Abdul Khalik Pasha, I'm calling you again. Are you there? No. Shiv Pavan,
Present, ma'am.
Alok, Alok is absent. Fine then, everyone, please take care. Have a nice day. I'll be posting by today without any cause the assignment of module 3. So see that you do submit at the earliest. So until tomorrow's class, take care and bye-bye, right? Be attentive. So tomorrow we are going to do the derivation part of load carrying capacity for hydrostatic bearing. So be attentive in the class. So we'll meet in the first hour then. Until then, take care and have a nice day. Bye-bye.
Thank you, ma'am.
Yeah, bye-bye.